So alternative to practical, this classified paper. And page number 35. The question is, old concrete contain calcium carbonate and that react with a hydrochloric acid. So calcium carbonate can react with a HCl or a hydrochloric acid, give off calcium chloride plus water plus carbon dioxide. Plan an investigation to find which two lumps of a concrete contain a large percentage of a calcium carbonate. Your plan should include how you will use your result to determine which two lumps has the largest percentage of calcium carbonate. You have access to all common lab material and a supply of a dilute hydrochloric acid. So here we have to plan an experiment to find what is the percentage of the calcium carbonate in the concrete. And as I mentioned, that containing large percentage of a calcium carbonate. Whenever such question is there, you have to write the formula as well, like how it can be done. The formula should be there. So first we have to carry out a reaction, and then usually when we have a large piece, as I mentioned here, the formula, how the percentage can be calculated, that we will do. So first thing, we have a plan and investigation to find which of two lumps contain the large percentage. So usually what we do, we will crush as I mentioned, lumps are there. So we'll crush the lumps of,
we should say, known mass of it.
Concrete. First we crush and then we'll measure the mass.
Crush using pestle and mortar?
Yes. So crush the lumps of concrete by using mortar and pestle.
Add into conical flask and add dilute excess hydrochloric acid.
Then now what we will do, like after crushing, we measure the mass. Because we have like two lumps of a concrete containing a large, we have to find which one of the two lumps. So we have like, you can mention, take first sample and then the second sample. Then we will take known mass of concrete, sample A or sample 1, or measure the mass by balance and then transfer into conical flask. So after transferring that into a conical flask, we will add excess of hydrochloric acid. After adding excess of hydrochloric acid, how we'll know we have more than enough hydrochloric acid?
When there will be residue left inside, it will not dissolve.
Yeah, no more reaction happen or no more reaction occur.
Then we can connect a gas syringe and delivery tube, or
But
we can place it on a balance tank.
Usually for gas syringe or
cotton wool.
If you want to measure the rate of a reaction, then we'll measure. But what we have to do, like in the question, we have a lump of a concrete.
Just place it on a balance with cotton wool.
We have a lump of a concrete, and this concrete contains high percentage of a calcium carbonate. So what we want to do, we want to find what percentage is there that it can, like what is the percentage of calcium carbonate in this. So measure the mass of concrete. Then when we add an acid, the acid will react with, when we add an acid, the acid will react with this. When acid will not react with all concrete, it will only react with calcium carbonate present in the concrete.
So, Mr., until no more bubbles form?
Yeah. Add excess of hydrochloric acid. Until no more bubbles.
We can also add excess hydrochloric acid and then see which sample has the most residue left.
But measurement is having a formula because you want the percentage. By looking at the sample, you cannot identify what is the percentage. By, like example, if I look, more mass is there, but I cannot identify from the looking at the mass that what percentage. So we add an excess of a hydrochloric acid until no more bubbles are there. Then we will filter and dry the residue.
They didn't ask for a specific percentage, though. So we
But
can
you
say
have to
which one has
mention,
more
you have to
benefits.
mention the formula to get the percentage. The for writing a formula is having a mark. As the question is, your plan should include how you'll use your result to determine which of the two lumps has the largest percentage. So how you determine that which is having a largest percentage? So there should be a calculation point. So add excess of a hydrochloric acid until no more bubbles are there and filter and dry the residue. Then what will the mass of calcium carbonate? Mass of a calcium carbonate will be equal to the mass of concrete minus the mass of residue. And after measuring the mass of calcium carbonate, how to work out the percentage? The percentage will be equal to, so percentage of calcium carbonate equals to mass of calcium carbonate times 100 divided by mass of concrete. And we'll repeat the experiment with the other sample.
But with the same mass.
Yeah, with the same starting mass. Look what actually happened here, like how this experiment is done. So when we did this experiment, how it is done? Say you have a sample of a concrete, okay? So this is a sample of a concrete. And the dots are representing what? The dots are example representing the calcium carbonate in the concrete. So first what we did, we measure the mass of, first we measure the mass of a concrete. Any mass is there, like example, say this is 2 grams. Then we crush this and we transfer that into a conical flask. So we took a conical flask, we crush this. So when we crush, it will have, like it will turn into small pieces and contain, the dots are representing the calcium carbonate. So these dots are representing calcium carbonate, okay? Now what we did to this, we add a hydrochloric acid. When we add a hydrochloric acid, as a result, when we add a hydrochloric acid, the calcium carbonate, which is represented by red dots, will react only. The concrete will not react. Only calcium carbonate present in a concrete will react. So concrete will remain there, but only the calcium carbonate will react. Then what we did, we filtered this. We use a filtration and we filter. So we are left with the sample of a concrete on the filter paper. And then we dry it, because if it is wet, it will have. Why we use excess of a hydrochloric acid? Because we want to make sure that all calcium carbonate is removed from the mixture. There is no more, like we will add hydrochloric acid until all of the calcium carbonate is removed. Otherwise, if we add limited amount of hydrochloric acid, maybe not all the concrete, not all the calcium carbonate react. Maybe some calcium carbonate still there. But we want to make sure that all calcium carbonate reacted. That's why excess of a hydrochloric acid is being used for this reaction. And when we use excess of hydrochloric acid, all the calcium carbonate is removed from it, because we want to remove all calcium carbonate from this sample of a concrete. Then we use a filter paper, like filtration, filter and then dry. And then we measure the mass of these remaining pieces of a calcium concrete. And then we compare, like how we'll know how much calcium carbonate was there. Say in the beginning of experiment, it was 2. And when we did this experiment, say it was 1.5 gram. So how much calcium carbonate was there in the sample? At the start, it was 2. And then after reaction, 1.5 gram of a concrete is left. So what mass of a calcium carbonate is there? So we just subtract. That's what I mentioned here. Mass of a calcium carbonate is mass of concrete minus mass of residue. This was a residue. And this was the mass of a concrete, which include calcium carbonate as well. And to get the percentage, mass of a calcium carbonate times 100 divided by mass of concrete. Is it clear, this experiment?
Yes, sir, clear.
Because we are finding the percentage of a calcium carbonate in concrete, that's why it is divided by mass of calcium carbonate, mass of a concrete. So the question 5, which is also related to the chemical reactions, student investigated the time to collect 40 cm cube of a hydrogen gas when magnesium react with dilute sulfuric acid. As you can see, using a measuring cylinder, 8 cm cube of a sulfuric acid was poured, and using a second measuring cylinder, distilled water was added. The apparatus is set up as shown. The bung is removed from a boiling tube. A coiled length of a magnesium ribbon was added, and the bung was immediately replaced, and the timer started. And the time taken for 40 cm cube of gas collected was measured. Student felt that the student felt the outside of a boiling tube. The student noticed that the boiling tube was warm. What does this tell you about type of reaction? If the boiling tube is warm, what does it mean?
Exothermic reaction.
It shows that
reaction.
it shows that the reaction is exothermic. Then describe one change that could be made to apparatus to help keep a temperature of a content of a tube constant. How we can keep
thermostatically controlled water bath.
Water bath.
Yeah, usually look, if you want to maintain a temperature, as we have, so the water bath is the best, like thermostatically temperature control. It's all a simple name for water bath, you can also say. So use a water bath. Insulation is when, even though you keep the insulation, but insulation is still the heat loss. Insulation minimize the heat loss or heat gain, but it's not like keeping the temperature constant. Even for example, if you have a hot drink like a tea is there in a cup, even it's a polystyrene cup is there, you keep a lid, you reduce the rate of cooling, but it's not like you completely reduce the heat loss or heat gain. That's why water bath is correct answer here. Then test tube was rinsed out with the distilled water. Then experiment was repeated using 10 cm cube, then 12, then 16, then 20. And 10 cm cube distilled water, then 8 cm cube, then 4, and then use the information. Use the information and description in the experiment and the timer, complete the table. So we have to complete the table for volume. Just a minute, I will, yeah. For volume and Time, it should be in second. As I mentioned here, it should be in second. You cannot write in minutes. So first experiment, volume of a distilled water which was added. The volume was distilled water. The first experiment, it was 12. Because the total volume is 20 for the solution. That's why it was 12. And how to read, like this is representing a minute. So 1 minute and how many seconds are there? This is representing, so this is 12 seconds. So 1 minute is having 60 plus 12. So that is 72. This is 0 minute and it is at 45-second mark. So this is 45. This one is 0 minute and at what mark? 30, 31, 32, 33. So this will be 33. This is 0 minute and how many seconds are there? 20, 21, 2 and 3. And this one is 0 minute and the time, I will just scroll down. So it's look 16. Okay, 16. So 72, 45, 33, 23 and 16. Then you have to draw a graph, draw a suitable scale for y-axis for experiment 1 to time for, because look, if you check the numbers, we have from 72 and the minimum value was 16. So we can start, as you can see, they did not mention anything. We want a smooth line graph. So if you start with 10, a suitable scale is needed. Like it can complete our, so I can start with 10. So if I start with 10, then $20, $30, $40, $50, $60, $70. Or if I keep that as 10 boxes equals to 20, like the scale you have to select. For example, if I select 10, then 20, then 30, 40, then 56, it won't cover that. So if I select this as 10, then 20, 30, 40, 50, 60, 70, because one of the value was 72 and then 80 will be there. So when you mark the points, the first one, this is the volume of sulfuric acid which was added. So volume of sulfuric acid which was added, the first one, the table, it was 12 and 72 was there. So 12 and 72.
Take 10 centimeter cube per second then on the y-axis per 10 blocks.
Yeah, you can increase the scale as well. This one is the volume of 8, 10, 12, 16. So at 8, the first experiment, it was 72. I'll roughly sketch. The second experiment, it was 45. The third experiment, it was 33. The fourth I'm just sketching because the time is short, so I will just sketch. Then 23 and 16. It was 8, 10, 12, 16 and 20. 23 and at 20 it was 16. So 16 will somewhat here. So we have to draw a smooth line graph. So this will be the smooth line graph. And then from your graph, what you have to do from your graph, deduce the time taken to collect 40 cm cube of a gas, repeat using a 9 cm cube. So what you have to do, you have to draw a line from 9 cm cube. Like draw a line from 9 cm cube and find how much. According to your graph, you will find how much gas is collected. And then what volume of a distilled water would be needed if experiment was